I will open the meeting, and I'd like to welcome everybody to this UK CCSRC webinar on reporting back from the Track 1 clusters and their CO2 transport and storage plans. So I think everybody's used to the protocol now. We've got 3 speakers. If everybody could keep their cameras and audio off while we've got the speakers. Feel free to type questions into the chat during this first half of the session. And we'll accumulate those questions, and then those will all, we'll go through them in the discussion later. Sorry, I've just lost my my Zoom screen. Just let me get that back when the slides came on.
Sorry, that was my fault.
Sorry about that. I'm back on now. No, I've just kind of messed up my screens there. I'm all back on again now. So we've got 3 speakers this morning. We've got an hour of presentations, and then we'll have a 10-minute break. You can all stretch your legs, and then we'll come into a discussion. It'd be lovely if everybody could participate in that discussion, put your questions in the chat or raise your hand. And if you would like to ask your question, then feel free to put your camera and microphone on, and we can sort of get a bit of a dialogue going. So our first speaker, I'm very pleased to welcome back Bryony Livesey, who leads the Industrial Decarbonisation Challenge within the Industrial Strategy Challenge Fund. The Industrial Decarbonisation Challenge is a £200 million programme with £260 million match funding from industry. And that's been designed to deploy low carbon technologies and enable infrastructure in heavily industrialised regions of the UK. And Bryony is going to give us an overview of the Industrial Decarbonisation Challenge. So over to you, Bryony.
Thanks very much, Claire. So it's probably only about a couple of months since I last had the opportunity to speak at one of these webinars, and one might normally expect it wouldn't be worth talking again only 2 months later, but a lot has changed. Of course, we've seen the announcements of the BEIS industrial clusters sequencing process, which have been exciting news for a lot of people. So what I'm going to do is just give you a very brief introduction to what we're doing on industrial decarbonisation through the Industrial Decarbonisation Challenge, so that you can start to see how the picture's developing. But obviously we'll be hearing from Ben and Martin, and we're going to take you through the detail of what's happening in their own projects. So I'll leave all of that to them. So just for people who might be a bit new to this area, what we're trying to do in the challenge is decarbonise clusters of industry. This is an example from the Humber, showing that we've got major industries located closely together. Here we've got refineries, combined heat and power, and then very closely close to there on the opposite bank of the Humber, we have the Salten Chemicals Park, which is also a key area to be decarbonised, and also a key area for building new facilities, such as a large new hydrogen production facility. So all of these regions, they need to be decarbonised, and we're pressing ahead with trying to make that happen. We have got a £210 million of public money to spend on this, and what that pays for is the initial stages of thinking about the decarbonisation plans and choosing the right technologies and doing the engineering designs to make sure we've got the right technologies, we understand the costs, we know the pipeline routes and all that kind of stuff. So this, for the benefits of people who are not familiar with the challenge, shows you where the major industrial clusters in the UK are situated. So we are working with projects in South Wales, in the Northwest, in Scotland and Teesside, and 2 projects in Humberside. All of these are really important industrial regions for the UK. We do not intend to see them disappear as we strive to reach net zero emissions by 2050. And so what we have to do is find cost-effective ways to transform industries in those regions. and help them to understand what the new infrastructure will mean for things like attracting major new investment in new production facilities, for example, and in thinking about the skills we're going to need in the region and all of the stuff that comes with a major change, which industrial decarbonisation clearly will be. And one of the things we try to do in the challenge is make sure that we deliver all these projects as effectively as possible, including an important element of knowledge sharing between the projects so that we can make sure we are doing the right things at the right time. So that's the clusters shown on a map. Just to summarize what they are doing, we're showing here CO2 capture and hydrogen production from natural gas as having a really major part of what we're doing in the industrial decarbonisation challenge. And you can see on this picture that these cluster regions are very important. There are a lot of jobs in those regions. They account for a lot of what goes on in the UK, and they also account for a lot of our CO2 emissions. So we're well underway with the programme now. What we're trying to do is reduce the carbon footprint of these industries, make sure that the investment comes along, and that we crucially want to make sure that these industrial clusters are on track to be operational by 2030 and heading towards achieving net zero emissions by 2040 or 2050 at the latest. So we've been running the programme now for 2 years. The projects are making great progress, and what we've also seen in the same period is a real increase in government policy to drive the ambitions of achieving net zero industrial clusters. So this picture shows what we've seen happening over the last 2 years. So when we launched the Industrial Decarbonisation Challenge, the government policy was what's seen as a fairly ambitious target at that time of establishing the world's first net zero carbon industrial cluster by 2040 and at least one low carbon cluster by 2030. And then what we saw in March 2020 was the idea of having maybe 2 sites decarbonised, and that was mentioned in the budget. And then we had the 10-point plan, which talked about 4 of these sites. And then we've seen this year the industrial decarbonisation strategy really putting in a lot more information to support exactly how this is going to happen, and confirming the 4 regions will be substantially decarbonised by 2030, which is great to see. And then we had the net zero strategy in October, which announced the ambition to deliver 6 million tonnes of industry-related CO2 capture by 2030. So that is a fantastic increase in ambition. But then what we're seeing now with the outcome of the industrial cluster sequencing process is that what we're now seeing is the first major investment into making these projects actually happen. So as I'd mentioned in the industrial decarbonisation, we're funding the engineering design work, and now the projects that have been selected to move first are planning now how they will move towards construction and to early operation. This doesn't mean that the other clusters are going to be forgotten about, and the challenge has not changed in any particular way to reflect the outcome of cluster sequencing, because it remains the ambition to have 4 substantially decarbonised regions in place by the end of this decade. And so that is still the plan, but it is absolutely fantastic to see, the announcement of the 2 track 1 clusters moving forward at an accelerated pace. And I'm really looking forward to hearing from Martin and Ben about their plans. Thank you very much.
Thanks, Bryony. So I think we'll just take all the talks straight away now, and then move into questions at the in the next session. So if anyone's got any questions for Bryony, make a note of them, and there'll be a chance to ask those later. So I'd like to invite Ben Kek now from the East Coast Cluster. Ben is a chartered engineer and fellow of the Institute of Engineering and Technology. And he's been working on the East Coast Cluster and its original component projects for nearly 3 years now, and he's involved right across the project chain from and the integration across the CO2 value chain. His career at BP has taken him to many countries with experience from upstream hydrocarbon sector down right along to the nascent CO2 sector. And yeah, he's going to talk about the East Coast Cluster, I think prioritising the kind of perspective of Teesside where he's based as well. So thanks, Ben.
Thank you very much, Claire, and thank you for the opportunity to tell you a bit more about the East Coast Cluster. I hope everything works. People can see my screen, full screen, yeah?
Yep, we can see that.
So I guess I just want to start by firstly kind of saying thanks to the UKRI, really, we are a grant fund recipient of in terms of progressing through FEED for the East Coast Cluster. And also, we're incredibly proud and pleased as well to be selected by BASE to be part of the Track 1 Phase 1 set of clusters. So what I hope to share with you today is a little bit about kind of why this project, how it fits in within the industrial decarbonisation challenge that Bryony talked about. Tell you a little bit about what the project actually looks like right now, and a bit about the time frame to demonstrate the kind of momentum that is rapidly building up, as well as hopefully ending with a little bit about some real examples of real impact that this will actually create with regards to jobs, etc. So my name is Ben Kek. I'm the Deputy Project Director for the Northern Endurance Partnership project. And we've got a website, eastcoastcluster.co.uk, which you're very welcome to visit after this. So a little bit about how we fit in. So Bryony talked about in its early stages, there was the Industrial Clusters Grand Challenge, the Clean Growth Grand Challenge, of which the Industrial Clusters mission is a core part of it. There were 6 clusters, and early on, as part of ETI OGCI project, where the idea originally came from, the ETI being the Energy Technologies Institute, which is a public-private partnership. The team there kind of went around and looked at various different sites and clusters, and basically identified some pretty interesting characteristics on the East Coast. On Teesside in particular, it's the most compact cluster of the 6 that you see there. And on Humber, it's clearly the largest spread, but also the highest emissions. And what's important really is to be able to tie emitters and emissions to where the stores are. And thankfully, the UK is blessed with the 4th best geological resource in the world for CO2 storage, and much of it is actually based in the southern North Sea, which is geographically ideally positioned to serve both Teesside and Humber. So you can see where I'm going here on why East Coast Cluster. Clearly, CCS acts as a backbone, as an enabler for industrial decarbonisation, seeing that with the range of industries that you can see in the diagram there, chemicals, fertilizers, ceramics, food and drink, cement, steel. There's really just 2 ways to decarbonize heavy industry if we want to maintain them in the country. And the UK has had a very long heritage and very advanced technologies as well for heavy industry, which also provides lots of jobs and scientific advantage, which we want to maintain. So the 2 ways are to capture CO2 from any sort of combustion process, post-combustion capture, or fuel switching, which primarily is about hydrogen. And I guess a lot of the audience here will know that blue hydrogen is the next step, the next kind of cheapest and greenest compared to existing gray hydrogen. And that will require CCS to take its CO2 away in order to enable that fuel switching as well. So lots of roads tie back to CCS. And if we look at the Committee on Climate Change's 6th carbon budget, you can see that there's a very large ambition indeed. What Bryony outlined was the net zero targets, but also there is a much broader vision that the government has consistently stepped up to, with the latest numbers being 20 to 30 million tons per annum by 2030 as a target for the UK as a whole. And that's coming from a position of zero. So it would be pretty much the fastest ramp up in the world. It will be, East Coast Cluster will be the largest CCS project in the world. And also by comparison, 20 to 30 MTPA is set against operational CCS around the world today of only about 40 MTPA for the whole world. So it's quite ambitious. And I think we're very keen to move from ambition into real projects and how we can actually help meet this target. So what exactly is the East Coast Cluster? As I mentioned earlier, you've got the most compact cluster in Teesside, and you've got the most spread out cluster but highest CO2 volumes in Humber, plus being very close to some excellent stores. The main one being Endurance, which is a saline aquifer store. It was originally explored back in 1970 and progressively worked through. Explorers were looking for hydrocarbons, but found a giant structure instead that turned out to be extremely suitable for CO2 storage. So you've got all these natural, geographical, and geological factors that really allows us to package this together as one mega cluster, East Coast Cluster, which would aim to decarbonize up to 50% of total industry CO2 emissions when you combine both Teesside and Humber, and potentially deliver up to 25,000 jobs per year by 2050, up to 2050. And a lot of that is to do with the types of projects here. So if I kind of move through, you'll see that this project, East Coast Cluster, we see it as our vision, and we have a delivery vehicle underneath it, which is the Northern Endurance Partnership, kind of quite aptly titled. The offshore component, everything you see that the green arrows that the offshore component plus the Teesside onshore component is going to be delivered by BP as the operator on behalf of the partnership. And the Humber onshore component, the Humber low carbon project, will be delivered by National Grid on behalf of the partnership. So we have a delivery vehicle here that's Northern Endurance Partnership, and two different operators covering two different parts of the scope, both of which have very unique characteristics and draw upon the unique skill sets of those operators, and also the expertise, the global expertise of past CCS and existing CCS operations around the world through that partnership, with Shell, Total, Equinor being a great examples of that. Within these clusters, you've got a series of different types of businesses that with the backbone of CCS will enable. So firstly, there is the actual CO2 transportation and storage. And really the business case there is quite simple. If you look at what's been happening with the price of carbon today, it's been rapidly rising. I think it's probably about 50, 60 euros a ton now. And as it continues to rise, you will get to a place very, very quickly whereby the system will be able to operate subsidy-free and will be a preferred way rather than emitting and paying the penalty, which is kind of damaging both sides. Much better to send it into the system and store it for perpetuity using nature-based solutions, which is the giant structure that I mentioned, that is Endurance, and beyond that as well. It will enable, if you have this backbone, it will enable clean hydrogen, as I mentioned earlier. So there's quite a lot of hydrogen projects being mooted in here. And then followed by some very large bioenergy producers today, chiefly Drax. By capturing CO2, it enables bioenergy with carbon capture, and that would allow for negative emissions, which is very important and is crucial towards getting to a net zero target for the cluster as well as for the country. It would also enable clean power with post-combustion capture. And there are a number of technologies associated with that. For example, CCGT with post-combustion capture, which is one of the two of the projects being mooted here. And what that would do, quite crucially, is provide the energy security and energy balancing as we deepen the penetration of renewables. So they balance renewables when they're not producing, but also provide grid stability. So the CCS acts as an enabler for all of these different technologies, and also the progression of those business models in order to make them realities. Now, East Coast Cluster as a successful bid, it's comprised of up to 10 million tons of CO2 captured and stored per year from the T-site cluster, and in its initial phase, up to 17 million tons of CO2 for the Humber region. And you can see quite a variety of logos in there, which I'll go through in a little bit more detail in a minute. But what I just wanted to highlight here, what is the East Coast Cluster about? Is firstly, it's about the diversity. Right? It's got a huge diversity of different industries spread out across quite a wide geography, which allows us to actually test lots of different ideas and projects quickly to find out which are the most efficient to decarbonize from post-combustion capture or fuel switching, for example, as you build up the hydrogen demand as well. It allows a diversity of capture projects, different and finally on different technologies. So for example, in T-site, because it's very compact, we can transport CO2 in gaseous phase, whereas across a wider geography, we would need to transport, for example, in Humber, we would need to transport CO2 through dense phase. And both of them going offshore will have to be transported in dense phase in order for us to get the kind of rates that we're looking at with the targets that's been set. So hopefully that is quite clear what the project is about. It's about providing this backbone of CO2 pipelines, compressors, and facilities offshore in order to transport and store the CO2 and help decarbonize industry. And just diving a little bit deeper then, in T-site it's much more compact. You can see there some of the distances between the edge of Billingham up to the River Tees. That's only about 7 kilometers, going all the way to the main site at Tees Works. That's probably less than 15 kilometers. So it's very compact. Most importantly, it uses a lot of the existing leeways, easements from what was one giant former ICI site. So there's a lot of rehabilitation, but I think crucially the environmental footprint would be quite low, particularly with a lot of reuse in what is also a very industrialized area. So there's a lot less impact in terms of adjacent neighbors and so on. You'll see here that there's quite a lot of different types of projects. I mentioned CCGT, combined cycle gas turbine with carbon capture that complements renewables, that's NZT power. You've got blue hydrogen being mooted there, quite a few of them. You've got oxy-fuel combustion in Wilton, and you've got energy from waste and fertilizers as well. Fertilizers and each one of them will have a slightly different path towards decarbonization. So for example, on CF fertilizer, one of the byproducts is pure food grade CO2. So that's very easy to capture, very low cost of capture. We fully expect CF, for example, to be one of the earlier emitters that will send CO2 into the network, given the low cost of capture. And there are others that will be a little bit more expensive, but they would create quite a big dent with regards to emissions in the cluster. So that we believe that there's going to be a combination, and BASE will ultimately decide and select on it. A bit about Humber, then you can see it's kind of much wider, so 7 kilometers pointed out there versus 50 kilometers here from Hull out to Drax. And again, quite different industries, quite a lot of blue hydrogen as well. There is also CCGT and carbon capture. You can see there with SSE Thermal and Equinor, and lots of combination of hydrogen hubs. The unique one obviously is Drax. Today it is a very large emitter, although it is biomass, which is a very different carbon footprint. And if we are able to take much of that CO2 away, it would allow for negative emissions and offsets. to help get the region towards net zero. So hopefully this gives you a bit of a feel as to what the configuration and the diversity actually looks like and what this project really enables. Now, a little bit about the process, right? How how all of this is actually going to work. So the East Coast cluster was one of 2 clusters selected, and the other one being HyNet, ENI, which we'll hear from my colleague Martin later. With the East Coast cluster, we are part of track 1, phase 1 selection, and phase 2, which involves the emitter selection itself, has been kicked off as of, I believe it was the 9th of November, and it will conclude submission will be at the end of January, followed by selection by base from around the May time onwards. So as a neutral TNS operator, we welcome any emitter looking in Teesside or Humber looking to connect. It doesn't mean that if they weren't identified here as one of the original primary emitters who expressed an interest in the bid will be excluded. That's very much not the case. Any party is allowed to submit an expression of interest per the base process. And once that is selected, it will allow us to then finalize the CO2 specifications, the route connections, what exactly is going to be built in the first phase, followed by progressive expansion. The ambition, obviously, the plan that we submitted to base calls for a ramp up of as fast as 20 million tons per annum by 2030, with up to 500 million tons stored by 2050. That's a very aggressive target, and it depends on which ones of the emitters get picked and selected by base, what the total project is actually going to look like, after which will allow us to reconfigure. An important point here then is that it's the timing. So clearly the climate emergency is urgent, and a big component about this project is its deliverability by 2026, started by the end of 2026. And if we work back from there, we will be looking to take FID, final investment decision, sometime in the middle of 2023. And we will be looking for, obviously, all of the emitters to be selected very, very soon in the next few months in order for us to go through the FEED design process and finalize the design so that we can really get into construction. So there's quite a lot of momentum now. The project is in FEED. The teams are ramping up. There's a lot of contractors being mobilized. We have 5 different contractors across, well, we have a host of contractors across potentially 5 different locations in the UK. And it's in a pretty exciting stage now as we move forward towards the design stage that's supported also by the UKRI. So I just wanted to give a bit of a feel, some pictures maybe about what it actually looks like on the ground. In Teesside, we've got Tees Works. That's one of the, I think that is the largest UK brownfield industrial site. It's got, I think, the 4th busiest deep water port as well. You can see a ship channel on the top left there, and which makes it really accessible for mobilization of large construction modules in order to build up the facility. And you can see that this is a huge legacy site that is just waiting to be regenerated. So what, in addition to enabling all these other industries, one of the key points here is that having that backbone, that CCS, the ability to take away the CO2, would also attract new investment into the region. There's been a few sweeteners that's been thrown in. For example, Teesside is also the site of one of the free ports, as is, I believe, one of the Humber sites as well. And that would only serve to increase the attractiveness. Plus, both Teesside and Humber has a host to quite a lot of offshore wind coming in via the substations nearby. And what that does is it also allows for easy access to green electricity, as well as the complementary CCGT, post-combustion captured power, to provide low carbon power overall to the industry. So got low carbon energy, low to zero carbon energy, plus the ability to take away your CO2. Things that come out of these clusters, we would hope would be truly green products, and I would hope would command a green premium as well for markets around the world, which makes it doubly attractive for new investment. The diagrams at the bottom just shows the overall full chain. So on the left, bottom left, that was that's the T-side development consent order consultation. So that's the red line boundary of the areas that where we will be locating new pipelines and new facilities onshore. Excuse me. For the one in the middle, that's the proposed route corridors in Humber, and that's currently under consultation. You're very welcome to have a look online. And both of them obviously will go through offshore pipelines out to the Endurance field, which has recently completed an EIA Environmental Impact Assessment Scoping Report, and will be progressing further along the EIA towards the storage permit in the coming year and a half. And finally, offshore, you've got a series of subsea infrastructure. It will be subsea pipelines and subsea trees that will keep the visual footprint to a minimum, but also really leverage the skills and the supply chain from the North Sea offshore industry. A lot of it is transferable, and this will represent a great ability to be able to enable that transition, not just for energy, but also for jobs and skills. And what I've shown there is where the Endurance geological horizon is. We'll be storing it in the Bunter Sandstone, which is very, very well understood, very well penetrated through all the hydrocarbon reservoirs in the southern North Sea as the store for the East Coast cluster. Final slide here, just in terms of economic benefits, I mentioned about the project being real. Hopefully, this gives you a sense as to seeing some of the pictures as well, what this is actually looking like. But just some of the headlines here around numbers. We could be supporting up to 25,000 jobs by 2050. You can kind of read through there just the impact that we'll be creating locally, which really excites me, because when you look at Teesside and Humber and you look at the legacy and the skills that we've got there, those used to be giant industrial sites. I think Teesside is still the largest chemicals production site for the UK. You've got those existing skills in place to be able to transition and enable this. Plus, you've got schools there, and to be able to bring in new apprenticeships in order to enable these industries to flourish. We'll build the backbone, we'll attract new industries, we'll build this out over a number of years by phases. And what I would hope is this project continues to grow, because if you look at the challenge of what we need to do in the 6 carbon budget, I believe when you do a kind of simple comparison, we'll be looking at CO2 injection of something like 1.5 times the size of the equivalent natural gas transmission network in the UK. So it's truly a very major project, and multi-years, multi-decades, that I think is a very good example of the energy transition that we're going through. And with that, I think I'll hand back to Claire, and I look forward to hearing a bit about HyNet myself.
Thanks, Ben. It's really great to kind of zoom in and hear a bit more of the detail of what's going in the East Coast cluster. That's fantastic. So I'd like to welcome Martin Currie now from the Northwest cluster, the HyNet cluster. So Martin is a senior commercial negotiator on energy transition with NE UK, and is director of the Liverpool Bay CCS company. Martin has over 35 years experience in the oil and gas industry, and his background is as a reservoir engineer and technical manager. And since around 2018, he's been focused on business development, leading NE's efforts to deploy CCUS in the UK. So he's going to, I think Karis is driving the slides for Martin, and talk about the HyNet Northwest cluster. Over to you, Martin.
Great, thank you very much for the introduction, Claire, and thanks, Ben, for a great presentation. Good to see you again. Good morning, everyone. Sorry, good afternoon, everybody. If we can just move on the slide, Karis, that'll be great. I'll start with the introduction to E&I and how the company is transitioning to address the challenges of a new energy environment. E&I is a major international company with interests in 68 countries worldwide, headquartered in Italy. We've got over 30,000 employees, of which around 500 are based in the UK. One of the fundamental objectives of our strategy is to achieve total decarbonisation of all of our products and processes by 2050. An ambitious goal that we intend to achieve by leveraging on the quality of our assets, technologies and skills. In this respect, our involvement in the HyNet Northwest cluster, an application of carbon transport and storage, fits well within this strategy and complements the many decarbonisation initiatives that we're applying to reach net zero as a corporation by 2050, which are highlighted on the slide. Our corporate targets for CO2 capture and storage are 7 million tonnes by 2030 and 50 million tonnes by 2050. Within this target, our TNS project with HyNet represents a significant and important starting point. As such, the project that I'll describe to you today is one of the most important projects for E&I. Next slide, please, guys. This is the HyNet Northwest cluster at a glance, a project to decarbonize industrial emissions and pave the way for a transition to a hydrogen economy. We can start at the CO2 storage infrastructure and work our way back up the chain of CO2 supply. We can see the offshore location of our Liverpool Bay assets, which will be repurposed for CO2 storage. And the red line indicates the route of the pipeline to transport CO2 to the store. It originates at the Stanlow Industrial Complex, which will serve as the hub for the supply of CO2 captured directly from nearby emitters. And these emitters include companies seeking to decarbonize their production from processes, including refining, fertilizer, cement manufacturing, energy from waste, biofuels, and hopefully a few others as well. In addition, located at the Stanlow refinery site, a new build hydrogen production facility is planned that will require CO2 capture as part of the process to ensure the supply of low carbon hydrogen initially to the refinery, and then as the hydrogen market develops to industrial users wishing to fuel switch from gas to hydrogen. And the white lines represent the expansion of hydrogen supply to these users, which will include power stations, glass manufacturers, steel production, and other users who require decarbonized high heat sources. As the market develops, hydrogen will also be available for the transportation fuels and potentially for dilution in gas pipeline networks, and eventually, perhaps, subject to government policy, to supply hydrogen for domestic heating. In order to match supply and demand of hydrogen, it'll be necessary also to incorporate hydrogen storage, which will be located in the salt caverns to the south of the Cheshire Salt Basin. E&I's role is to be the CO2 transportation and storage provider that will enable the development of this strategic project. And we're working with a number of other major collaborators to provide an integrated CCUS project of major proportions. And our TNS infrastructure is planned for startup in 2025. The Liverpool Bay Area fields are capable of storing at least 190 million tonnes of CO2, with initial design rate capacity of 4.5 million tonnes per year, which can be later expanded to 10 million tonnes per year as the full project develops. The overall project will have a significant and positive impact on the regional economy, creating over 6,000 permanent new jobs with an estimated gross value added of £2.8 billion between 2022 and 2030. So if we can move to the next slide, please. HyNet is driven by a combination of committed consortium to deliver the project with a strong regional demand for decarbonisation of industrial products. On the left-hand side, we've got the companies most closely involved with the delivery of the project. And the FEED studies required for this full chain CCUS initiative are being jointly developed with the financial support, thanks to Bryony and her colleagues of the UK government funding, coordinated by collaboration agreements between parties to ensure coordinated delivery. And on the right, we've got the companies who benefit from the project, either by direct capture of their emissions or supply of hydrogen for fuel switching. A diverse range of customers, including many well-known brand names such as Kellogg's, Heinz, Pilkington, Heineken, who've all declared an interest in receiving hydrogen as a low carbon fuel source. This list is growing, and we look forward to more interested parties emerging through the phase 2 cluster deployment process and beyond. And what's extremely interesting is the demand side equation. This significant demand for decarbonisation can now be unlocked with the ability to store CO2 through the ongoing activities of E&I related to the development of the TNS infrastructure. Next slide, please. So now we concentrate our attention on the TNS project specifically. And at the heart of this project is the repurposing of E&I's existing oil and gas assets in Liverpool Bay. And this slide shows the existing infrastructure. We're currently producing oil from the Douglas field and gas from the Hamilton North and Lennox fields. The Douglas platform is at the hub of the production, where oil is exported via offshore loading and gas is exported from the wellhead platforms via an offshore gas pipeline from Douglas to the point of air gas terminal. This gas is then transported via an onshore gas pipeline for use at the Connors Quay power station or entry into the gas network at Connors Quay. The Liverpool Bay fields have been in production since the 1990s, and all the fields are highly depleted and close to their economic limit for production. Without repurposing for an alternative use, these assets would be decommissioned with commencement of abandonment prior to 2025. So the assets are all in good shape due to the active integrity checks and ongoing maintenance, and will be fit for purpose for CO2. And it's been a benefit that the facilities were designed for sour service, and the existing pipeline metallurgy is fully capable of handling CO2. We're very fortunate to have such an asset so close to the market demand for decarbonisation, with excellent cost and delivery benefits for repurposing versus a new build facility for CO2 storage. And the photos on the right-hand side show the Hamilton wellhead platform, the Douglas central processing platform, and the point of air gas terminal. Next slide, please. This slide shows the license area awarded by the OGA to E&I UK in October 2020 for the appraisal of CO2 storage. The license area, CS004, contains the 3 fields that we propose for CO2 storage: Hamilton, Hamilton North, and Lennox. And it also includes the area around Douglas platform, since we intend to incorporate this facility into the overall project area, using Douglas as a hub for the distribution of CO2 into the 3 depleted gas fields. And it's our intent to simultaneously inject into all 3 fields to provide the maximum capacity and maintain reservoir pressures as low as possible, such that we can remain in the gas phase for an extended period during the initial phase of the project. And this approach provides flexibility in the event that there are any operational problems with any one of the 3 storage sites. And we're working closely with the OGA on an agreed work program whose primary intent is to establish and justify the safe and permanent containment of CO2 in our reservoirs. The plan envisages a storage permit being awarded within 2023. Next slide, please. This slide shows each of the 3 storage reservoirs with the well requirements needed to inject up to 10 million tons of CO2 per year. In total, there are 8 injection wells plus 5 wells that will be used for monitoring and observation of CO2 distribution over time. The injection wells will be sidetracks of existing wells. This allows the appropriate completion metallurgy and CO2 resistant cement to ensure safe containment of CO2. The sidetrack of wells offers cost savings versus new drill wells, together with reduced carbon footprint to deliver these wells. And it also allows for the optimum well location placement as defined by our reservoir simulation studies. Next slide, please, Karis. The repurposing of our facility, whilst highly deliverable and relatively non-complex, doesn't come for free. There's a significant work program that's also being integrated with the decommissioning of those assets that would not be required for CO2 storage. So in summary, all existing wells will require to be plugged and abandoned, and injection wells sidetracked and recompleted. And for each of the wellhead platforms, we'll need to decommission and remove the redundant equipment and piping. A new module with helipad will be required, new electrical heater subject to flow assurance requirements, new instrumentation, telecoms, control panel, safety systems, and a designed-in provision for ease of conversion to dense phase operations in the later life of the project. For the Douglas platform, this will continue its role as a hub platform with a new module to be placed on the weather deck and a power cable connected from point of air. The Douglas drilling and accommodation platforms will be removed. As mentioned, the plans to integrate decommissioning and CCUS construction to maximize cost synergies. Next slide, please, guys. Further to the last slide, we're making use of depleted gas fields whose geology and dynamic behavior is well understood to us. This reduces risks in terms of our understanding of how the injected CO2 will be distributed in the reservoir. These are fields that have contained hydrocarbons for many millions of years, proving the geological trapping mechanism essential for the safe and permanent storage of CO2. As well as the repurposing of offshore infrastructure, we'll also be making use of the existing onshore gas pipeline between Point of Air and Connors Quay. This line has the capacity limit and has a capacity limit and ultimately needs to be replaced as we move to a later expansion phase to enable higher rates of CO2 injection. Even if this might be considered a drawback, it does offer us flexibility in the early stages and value for money through right sizing at the right time, depending on the rollout of demand for storage services. We're also able to make use of the existing gas terminal at Point of Air, repurposing and decommissioning what's not necessary for the control of CO2 transport from onshore to offshore. The Point of Air site will be the site of our compression station to be expanded as compression needs increase as our depleted gas fields fill with CO2. So the benefits of reuse, or more correctly, repurposing, is essentially lower cost, lower risk, and more reliability. Lower capital and operating costs through less compression requirements, given that the storage sites are initially at very low pressures, and lower capital costs through the use of existing infrastructure. Lower risks through extensive knowledge of the storage reservoir, and more deliverability through what is a less complex development project. So this, we believe, offers value for money to consumers, which is fundamentally important given the significant financial support which will be required from the consumer and taxpayer, at least in the initial stages. So we trust that our project can represent a great exemplar for the oil and gas industry in energy transition. Next slide, please. Regards the onshore section of the transportation infrastructure, this slide shows the preferred route of the onshore pipeline, the backbone used to transport CO2 from the Stanlow industrial complex to Point of Ayre. The dark green line shows the existing section of gas pipeline to be repurposed between Point of Ayre and Connah's Quay. The yellow and brown lines show the new build section of line required to link Stanlow to the existing pipeline at the Flint above ground installation located close to Connah's Quay. The development consent order, a DCO, is the planning mechanism required for this strategic pipeline. And this process is underway with environmental surveys and ground investigations being currently performed. Informal public consultations have been held with generally good support regionally for the proposals. Formal submission of the DCO will be made next year. The DCO approval from the Secretary of State remains on the critical path for our first operational date in 2025. So this stage of the process is vital to our timely delivery of infrastructure. Next slide, please. This slide shows a schematic of the TNS scheme and key technical parameters, flexibilities, and constraints. And the project build-out occurs in 4 stages. The initial stage, where the reservoir pressures are low, requires no compression requirements other than the compression required by the emitters to enter into the system at around 20 bars. As the reservoir pressure builds, we enter the next stage where compression and gas cooling are required at Point of Ayre. Stage 3 is the period of plateau governed by the capacity limit of the existing onshore pipeline. During this stage, pressure control and heating will be required at Douglas. For all the stages 1 to 3, the CO2 will remain in gas phase throughout the entire TNS system. Ultimately, the pressure conditions in the reservoir will require conversion to dense phase. And this will be the opportunity to remove any existing constraints, for instance, by adding an additional new onshore pipeline, and upgrade compression, temperature, and pressure control facilities. And we see this final stage as an incremental project, an expansion phase to be covered within a new price control environment within the economic regulated regime. Regards the flow assurance, it's worth highlighting that at all stages in the TNS system, the onshore transport of CO2 will be in the gaseous phase. The dense phase will occur in stage 4 and only in the offshore section of the system from Point of Ayre to the storage sites in Liverpool Bay. The flexibilities in this scheme, which represents considerable advantages in our view, allow for incremental and staged investments responding to actual demand as it becomes realized. Next slide, please. The key milestones of the project are shown here. E&I entered FEED for the TNS infrastructure in early 2021. And we were obviously delighted that the government nominated the HyNet cluster as track 1 on October the 19th. Our intent is to reach final investment decision in 2023 for infrastructure to deliver the stages 1 to 3 described previously, providing an initial capacity of around 4.5 million tons per year. The project startup is planned for 2025, commencing in this free flow stage 1. The ramp up of CO2 rates over the early years actually will depend on the outcome of phase 2 and understanding the volumes of CO2 that we will take on board subject to the processes that are currently ongoing. The next stage of expansion to 10 million tonnes per year again depends on demand and can be timed appropriately. Common with other cluster developments, the development of CCUS in HyNet cluster will have a significant economic benefit in terms of job creation and gross value added. And critical is the protection of existing jobs in the manufacturing sector, so vital for the region as pressures to decarbonize increase. Next slide, please. So, beginning to conclude the presentation, the key features of the TNS system are low cost through repurposing of existing oil and gas infrastructure, low risk through multiple storage sites, proven subsurface knowledge, flexibility, low initial cost, very scalable, and expansion will be driven by demand. Location, we're adjacent to a large industrial center, easy access to existing CO2 emitters, and ideally located to enable and support future expansion of a regional hydrogen hub. Next slide, please. So, my last slide illustrates the key messages from the HyNet cluster, where our TNS infrastructure enables an exciting integrated picture for decarbonisation to emerge and become reality. It really is a game changer. The cluster alone addresses significant elements of the UK government stated decarbonisation policy. 25% of regional emissions can be abated through this initiative, which is a significant impact. So this is not just industrial emissions, this is all emissions. The integrated project can be delivered rapidly. We believe the project is affordable, assisted by the relatively low risks and repurposing of existing infrastructure. It creates the environment for green growth. Already, the project is attracting new investment as a consequence of the future availability of the TNS infrastructure. So this is an exciting future, and we'll be happy to keep you abreast of progress, recognizing our responsibilities for knowledge sharing and learning by doing. With that, thanks for your attention.
Thanks, Martin. And I'd like to thank all our speakers very much, and all of you individually for keeping so well to time. We're on absolutely perfect timing. So at 1 minute to 3, we've now got a 10-minute break. Keep your questions coming in. There's lots of questions in there in the chat already, which we'll come to. And I'll try and group them as far as I can. So if we could come back at 3:10, then we'll resume with a good 50 minutes of discussion. I'm confident we're going to have quite a lively debate from that. So I'll see you in 10 minutes. Thank you.